Okay, guys, today we are going to start reviewing for the chapter test after we go over the sphere surface area and volume formulas that we talked about yesterday. Keep in mind your chapter 10 test is Tuesday. There is a lot of information on that, okay? There are a lot of formulas, which is why I didn't like saving this chapter till the end of the year, because I'm sure you guys realize by the time May comes, you're kind of ready for summer. So not a good chapter to save till the end of the year when you guys are starting to slack off a little bit. What I suggest and recommend that you do is either make flashcards or make kind of like a study guide for yourself and list out the formulas that we've talked about in this chapter. I'm leaving that up to you since you guys are an accelerated class. Okay, but I'm giving you that recommendation, especially if you keep messing up with certain formulas. If you feel pretty confident, don't worry about that. But if you're like, some of them I'm a little iffy on, I'd either make flashcards or kind of list them out on a blank piece of paper. That way you can keep looking back at them to make sure that you know the formulas and you know when to use each one. Okay, this is something I even did in grad school when I would take finance and accounting classes. It's okay to make little cheat sheets for yourself to study from. You're not going to use it on the test, but just to get yourself prepared for the quiz next week, the test I should say. No formulas will be given to you. Okay, so you want to make sure that you know them all. It goes all the way back to 10.1, all the way up through 10.9. The only thing you haven't been quizzed on is volume. That's the kind of like the last thing we did. There's not as many formulas for volume. They are a little bit more simple, so I feel like you guys will be okay just adding that in. As long as today goes well, Monday will be either whiteboard day or review game. Excuse me. I haven't decided yet. I want to see how today goes. Okay? All right, so I want to start with, did anyone make their complicated figure? And, okay, let me say thank you. And if you haven't, oh, that's awesome. I can't wait to look at this. If you haven't yet, you can give that to me on Monday still. And I'm not going to show anyone. Did you show anyone yours yet? Okay. Mary, the ones with the little dotted lines, are those holes? Okay, good. So what I'm going to do when you guys do give them to me is I'm going to have some fun and check them over to make sure that your work is correct, and then I'm going to grade them, okay, based on my rubric that needs finished. Emma? Yeah, man, you guys are awesome. I'm going to miss you guys next year. This is so fun. That's up to you. You don't have to. You just did volume. Annalise? Yeah, just a bonus. You don't have to do this. This is just something extra. I'm going to give you guys bonus points for it. I haven't decided how many yet. I need to make the rubric so I'm consistent, though. Yay. Yes, when I'm done with it. Yep. Yep. I'm hoping this weekend. Not today, because it's too hard with teaching all day. I like to take my time on that. Charles, I'm sure if you do something that's complicated in your mind, that you'll end up getting full credit for the bonus points. Do you know what I'm saying? You end up getting... Okay. Make sure you have regular units on there, too, for us, okay? All right. Any other questions? Sean, you okay? Well, we'll talk about that later. Okay. All right, guys. So let's start with the warm-up. Okay, and let me shut one of these lights off. I actually would like to start with the closing. Let me just go make a blank screen for that. Okay, so Zach and Adam, since you guys aren't here, we're in our notes on the closing, page 38 in your notes. They did A through C. All right, so letter A asks you how much gas will it hold? And they gave you some dimensions of the sphere. So Mary, what did you get for A? Good job. Okay, letter B says if you double the radius, will the tank hold twice as much? Donatus? Good, it will hold more than twice as much. Did you calculate what the volume is? What did you get for the volume if they double it? Well, I thought you said you got it. Oh, okay. Emma H? Correct. So It holds more than twice as much. How much, Mary? Good. It holds 8 times as much. So to answer your question, to answer the question, it would be beneficial if you put down what you got for the volume and then how much more it held. Correct. So your answer could still be yes, it does hold twice as much, but that's not the exact correct answer because it holds more than that. So you're right, Charles. It can hold twice as much, but it holds more than that. Okay, C. Suppose you downsize the tank so that the radius is 9 feet. How much gas will it hold if you downsize? Sean? Why? Wait. 4 pi radius squared is for surface area. We're doing volume. 4/3 pi r cubed is volume. You did 4/3 pi r squared? Yeah. Okay. Did you look back at your formula in your notes? Okay. Well, you wrote it wrong. Okay. All right. Just be careful. I won't call on you for homework, but just take your time. Look back. I would look back at your notes just to double check. I know you did it during class, but Matt. Good. And what are the units, Matt? Good. All right, so that was just our closing that I would have liked to have gotten to yesterday, but I didn't have time. Questions on that part of the warm-up before we go to the hard problem? Annalise? Oh, yeah, actually, that's a good idea. Yeah, you know what, guys? Stay in your notes. Thanks, Matt. From an organizational standpoint, Matt brought up a good point. Let's go over the homework, the ping pong and golf ball, so you don't have to flip back. Good idea. Thank you, Matt. This is why we have you in this class, huh? All right. So the ping pong, volume of the ping pong, Doug, is what? Mm, 0.3 millimeters cubed or squared, Doug? Good. Okay, that's fine. Surface area, Briar? Good job. Oh, not good job, sorry. Briar, you and me are on the same page today, apparently, right? Squared. Hey, I'm telling you good job, and that's not right. Sorry, surface area is squared. Hey, it happens. Mary, golf ball, volume. Perfect. Okay, let's try this again. Charles, surface area. Okay, give it to me multiplied by pi. 7 point. You're right, but I just need everyone else probably has the regular one. Okay, inches what? Good. Okay, so before we go back to that other warm-up problem, Alyssa. Wait, okay, so what was your second part? You kind of got quieter there. And you don't know what you do. Okay, volume of the ping pong. So first of all, did you divide 40 by 2 to get the radius? Okay, so you should have 4/3 times 3.14 times 20 cubed. So I would put in parentheses 4 divided by 3 times 3.14 times 20 cubed. Okay. I'm guessing it's a calculator issue. If you type something in wrong, remember those calculators are not as smart as you guys. You have to have those parentheses. I don't know, maybe you typed a number in wrong. Okay, Justin. Yep. Okay, anyone else on the golf ball or ping pong? Surface area and volume. Kind of a neat problem. More real life examples there. Okay, so let's go back to the warm-up. So that's 12.6. This will work out nicely. Let's go over the number 16. So guys that are absent, this was from the homework from yesterday. 12.6 on the back from your homework packet, number 16. Okay, this was definitely a challenge problem. Okay, surface area and volume you had to find. So the chances of all of you getting both of these right, I'm not sure, but let's see. Yes. Did you read the directions? Okay, Justin, surface area. 602? No, you probably forgot to get rid of the top of the base of the cylinder. Remember, surface area. Matt? Awesome. Great, great job. Okay, there's surface area. Who wants to try volume? Annalise? Nope. I don't know what you'd, I'm guessing something on your calculator. Briar? Awesome. Centimeters what? Okay, just making sure you and me are back to normal here. Centimeters cubed. All right, so let me start with volume. Okay, volume of the half sphere, which is the hemisphere, you should get 452.16. So if you missed volume, make sure you're checking. Volume of the cylinder should be 452.16, and then you add them together. That's how you get what Briar told us. Surface area, actually, let me stop for a second. Questions on volume? Sean? Sure. Annalise? Yeah, area of the base times the height for volume. Doug? That's fine. You probably rounded somewhere that I didn't. I just kept mine exact. All right, so surface area. Surface area of the cylinder, that's with taking off one of the bases, is 263.75. And surface area of the sphere, but taking half of it, sorry, I can't read my writing, is 226.08. So for surface area, you take half the sphere, and then for the cylinder, take off one of the bases. So when you add 263.75 and 226.08, you get about 489.84. Yours might be a little slightly different depending on how you rounded. Those are some good bonus questions. Annalise? $226.08. Okay, did you do 4 times pi times r squared divided by 2? Yeah, it's a hemisphere. It's half of a sphere, so you have to bless you. No, you're not subtracting anything. Oh, yeah, that's the way you do it. I forgot. Yeah, the cylinder, I just take off one of the bases. You subtract the base. That's fine. No. Okay, Annalise, listen. 4 times pi times 6 squared. Hit enter, and then divide by 2. Does this, no. Nope, don't subtract anything from the sphere. It's a hemisphere. Don't subtract anything. Technically, there's not a side of a circle, even though it's half of it. Don't subtract anything. When you do the cylinder, you're taking off one of the bases. Because think about it. When you're finding surface area of a circle, okay, you're finding the distance around. When you're finding half of it, you're finding the distance around half of it. You're not finding the bottom. It's the distance around half of it. Okay? Circle doesn't have sides. Yeah. Okay. All right. Anyone else on that? Give me a thumbs up, thumbs down on that hard one. Just curious. It's a good bonus for Tuesday. It makes you guys think on a Friday. Sean, do you have a question? For which one? No, no, for each of them? Okay, so surface area for your cylinders, 2B plus pH. But take off the 2 in front of the B because there's only one B. And then surface area of a sphere we just did yesterday. So 4 pi r squared divided by 2 because you only need half of it.
Okay, I think I just keep on comparing the bases, like where to take off and where not.
Yeah, so like the cylinder, Sean, you don't need this top of it. So that's why you get rid of the 2B, the 2 in front of the 2B plus pH. You'll need one of them. And then the circle, or the sphere, you're not finding the surface area of the whole sphere, that's the distance around, you're finding the distance around half of it.
Okay.
So that's why you divide it by 2. Sure? Okay, make sure at some point you try that again to make sure you get it. Mary? What'd you say? Okay. Anyone else before we go over homework? All right. So I'm going to make up some more of those hard ones for Monday as a warm-up, just for practice. Okay, let's go over practice 12.6. Okay, Emma M., let's start with you with number 1. Okay, did it say to round to round to 2 decimal places, so 0.06 centimeters squared. Briar, number 2. This should be a little higher than that. Sean? Good, 28.27 inches squared. Annalise, number 3. Okay, I have 0.75, but it's close enough. Depends on how you round it or what you used for pi. Mary, number 4. No. Charles, number 4. No. Melissa? Yep. Number 5, Emma H. Say that again. Good, 3.5 or 7/2 centimeters. Doug, number 6. Good. Justin, number 7. Say that again. No. Did you find half of it, which is 1 hemisphere? Okay, Matt? Good. Matt, you like these spheres, huh? Centimeters squared. Number 8, Annalise? That's fine. Remember, I always tell you, as long as you're close, that's not that big of a deal. You're good. Annalise, go ahead and do number 8 for us. Okay, I have 901.17. Do you guys all have 1900 or 1901? Okay, then it's me that's off. Annalise, say that again, 1900 point. Yeah, that's fine. I'm thinking I used the pi button on these, and well, actually, no, that wouldn't be possible. What did I do here? I probably rounded my squared differently than you guys. Yeah, so you're fine, whether you have that or 1901.2. Jeremy? Yeah, sure. Yep, awesome. Okay, feet cubed, Briar, number 10. Good. Matt, number 11. No. I think you forgot to take that 16 and divide it by 2. 16 is the diameter, not the radius. Oh, okay. Okay. Charles, number 11. Give it to me regular, please. No. No. Alyssa? 43.57. Okay. Units, meters, what, Alyssa? Good. Okay, number 12, Sean? Oh, yeah, that's right. I forgot. Emma H? Good job. That was a tough one. Yep, good. That's great. Great practice. Number 13, if you did go ahead, is 4.83 centimeters. 14, if you went ahead, is 3.31 meters. Good job. All right, Doug, question. The cube root, under the math button, or let me tell you, under the math button, or Doug, taking the cube root is the same. Doug, you listening? Taking the cube root is the same thing as raising something to the 1/3 power. Just like taking the square root of something is the same thing as taking something to the 1/2 power. Do you understand that? I use both ways. I'm just trying to help you guys think through that. Yep, same thing. I guess. I didn't do that in my head, so I guess. Emma H. Yep. Okay, guys, if you have a question on 4, listen, so I don't have to repeat myself. Go ahead. You got what? You got D. Okay. I know why you got D. Okay, let me write this one up here. Okay, so 4, you were given that the surface area is 40 pi, which is equal to 4 pi r squared, which is the surface area formula. Are you okay for now? Or did you already figure out what you did wrong? Okay, let me keep going. So if you divide both sides by 4 pi, 4 pi cancels. 40 divided by 4 is 10. Pi divided by pi is nothing, just 1, they cancel. So 10 equals r squared. Your answer cannot be 10 because you have to find what r is, not what r squared is. Square root both sides, you get 3.16, which is B. I know you look confused because you don't know what you did wrong. That looks really easy, I'm sure, right? So why don't you, at some point on your own, make sure you redo that and you understand why you get B. Okay? Alyssa? Number 8, okay. Number 8 is actually kind of like 4. Okay, you're given circumference, which is 24.6 pi. So I set that equal to 2 pi r, which is the circumference formula. And then find r, because you can't find surface area until you know what the radius is. Divide both sides by 2 pi. These cancel. Pi divided by pi is 1. 24.6 divided by 2 is 12.3, which is equal to r. And then once you have your radius, you can find surface area, which is 4 pi r squared. So 12.3 squared times 3.14 times 4 gives you about 1900. Okay. You okay? Emma? Wait, what did you multiply? Oh, you can do that. Yeah, that's the same thing. Yeah, it's easier if you just divide them out, but it's the exact same process. Yeah, good question. Annalise? Okay, 11, you should take 8 squared times 3.14 times 4/3. Yes, whoops. Sorry, Annalise. Can I have your pencil? I have many troubles writing here. Sorry, Annalise. Here I'm helping you and you're helping me. Yes, 8 cubed times pi times 4/3. Too many cubes and squares. 2,144.67, about that, depending on how you round. Okay. Maybe you did what I did and you didn't cube it. Oops. Okay, so 12 you're given, volume is 64. We have 4/3 pi r cubed. So I probably did this a little differently than you, so let me kind of do it the way you did. Oh, that's why. That'll take care of that. Emma H. Okay, ready? Number 9. You should have 4/3 times pi times 7 cubed. I think you might have just typed it in wrong. I'll say it again. 4/3 times pi times 7 cubed. You could be doing your homework, Jeremy, while I'm going over this. Okay. Doug, you had your hand up. Are you okay now? Okay, did you write did you set this up correctly at first? Okay. So, Doug, what did you do first to solve? Okay, so after you multiply both sides by 3, tell me what your next step looks like. Okay, hold on. Okay, so you have 192 equals 4 pi r cubed. Divide both sides by 4 pi. So what I would do on your calculator is take 4 times 3.14 and then divide. The same thing. So tell me what you get. Whoa, say that again? That's not right. Doug, did you do 192 divided by? Oh, you know why. I know why. You can't do that. Your calculator doesn't realize that 4 pi goes together. If you do it that way, you have to have parentheses around 4 pi. So type in 192 divided by parentheses 4 pi. Now tell me what you get. Yeah. So 15.27 equals r cubed. Then you cube root both sides or make it to the 1/3 power. That's the problem. Remember, I'm telling you guys, these calculators are not, you think that they can do everything, but they can't. That's why parentheses are extremely important. Annalise? No. 2.48 or 2.5. Okay, we just did most of it. So at this point, Annalise, you just cube root both sides. You multiplied 64 times. Okay, hold on. Okay, yep, so you get it. 48 equals pi r cubed. Okay, then you divided both sides by 3.14. So what's 48 divided by 3.14? Yep, so it's the same thing I have here. It's the cube root. Annalise, cube root. It's under the, listen, it's under the math button. You'll see, yep, thank you, number 4. Okay, or you can put it to the 1/3 power. 1/3 power is the same thing as taking the cube root. Guys, this is a hard problem. Remember I told you yesterday I was going to give you a challenge problem? Okay. Yeah, this is from the geometry book, which is 2 years ahead of where you are now. So that's kind of 4 years ahead of 6th grade. But it's okay. You can do it. All right. Any other questions? Okay. Who can remind me what the surface area formula of a sphere is? Mary. Good. Who can remind me what the volume formula of a sphere is? Alyssa. Nope, nope. Careful. Volume of a sphere. You said it backwards, the fraction. Good. R cubed. Good. So volume of a sphere, 4/3 pi r cubed. Okay, Breyer. Breyer, what is the surface area formula of a pyramid? Nope, nope, nope. Surface area formula of a pyramid. Surface area. Here's a hint. Base plus. Okay, I can get you help. Annalise? Good. Base plus 1/2 PL. Okay. How do you find volume of a prism? Volume of a prism. I'm just randomly asking. Charles, volume of a prism. Okay, what does that mean? What does the B mean? Good. Area of the base times the height. How do you find surface area of a triangular prism? Justin? Triangular prism, surface area. You had your hand up, you forget now. Nope. Surface area of a triangular prism, Sean. Good. 2B plus pH. How do you find area of a parallelogram? How do you find area of a parallelogram? Come on. Mary? Good. Base times height. How do you find area of a trapezoid? Doug? No. Not yet. Hold on. Okay. You have your hand up. It should be to answer the question. Annalise? Good. Say that again for everyone. Good. How do you find volume of a cone? Volume of a cone. You guys got to think because you need all this for Tuesday. Jeremy? Volume of a cone. All right. Annalise? Good. 1/3 times area of the base times the height. Okay. I think that's all I'm going to ask for now. Questions on that? A lot of stuff. Go ahead, Doug. What's a trapezoid? I'm not very good at... Kind of like this. There's one great drawing of it, but kind of like that. They could look many different ways. Jeremy? Okay, I just said that a couple times. Go to the math button. Number 4 is the cube root. Okay, good. Make sure you see it. Emma M can show you if she's sitting next to you if you can't find it. All right, open up your book to page 812. And we have about 10 minutes. I would like you guys to work on numbers 1 to 28. Okay, so I'm going to stop the recording so I can kind of walk around. If you guys would like to work with someone for the last 10 minutes, that's fine. Numbers 1 to 28 is your review from the book. Hold on a sec, okay.